In the past decade, quantum computing has emerged from the confines of theoretical research to tangible, albeit early-stage, applications in various fields. With its complex models, massive datasets, and the relentless quest for computational speed, finance can gain significantly from these developments. This video delves into the potential of quantum computing to revolutionize the financial sector, the challenges it presents, and the future it promises. The basics of quantum computing. Before examining the implications for finance, it is crucial to understand the essentials of quantum computing. Unlike classical computing, based on bits representing either 0 or 1, quantum computing uses quantum bits or qubits, which can exist simultaneously in multiple states thanks to superposition and entanglement principles. This characteristic could allow quantum computers to solve specific problems much more efficiently than classical computers. Quantum computing's entry into finance. The financial industry has always been a frontrunner in adopting innovative technologies that can provide a competitive edge. Quantum computing is no exception, as it has the potential to perform complex calculations at unprecedented speeds, a capability that is attractive for numerous financial applications. Potential applications in finance. Portfolio optimization. One of the foundational tasks in finance is portfolio optimization, which involves finding the best allocation of assets that minimizes risk and maximizes return. The problem becomes exponentially complex as more assets are added to the mix. Quantum computing could analyze countless potential combinations much faster than traditional methods. Risk analysis and management. Financial institutions must constantly assess and manage risk. Quantum algorithms are particularly well suited to simulate financial scenarios and calculate the probabilities of various outcomes, which can vastly improve risk assessment processes. Algorithmic trading. In high-frequency trading, algorithms execute trades within fractions of a second to capitalize on market opportunities. Quantum computers could process complex trading algorithms much faster than classical computers, potentially yielding significant profits. Credit scoring. Quantum computing could transform credit scoring by rapidly analyzing vast amounts of financial data and personal information to assess the creditworthiness of individuals or companies with greater accuracy. Fraud detection. Quantum-enhanced algorithms could detect patterns indicative of fraudulent activity more effectively than classical systems by sifting through complex, high-dimensional data. Challenges and considerations. Despite its promise, quantum computing in finance is not without challenges. Nascent technology requires substantial investment in research and development. There are also important considerations regarding cybersecurity, as quantum computing has the potential to break current encryption methods, necessitating the development of quantum-resistant encryption. Technological hurdles. The development of stable qubits, error correction, and scaling up quantum computers are significant technological hurdles that must be overcome before widespread application in finance is feasible. Regulatory and ethical implications. As with any disruptive technology, quantum computing raises regulatory and ethical questions. Ensuring fair access, preventing misuse, and maintaining privacy are all issues that regulators and financial institutions will need to address. The road ahead. The journey of integrating quantum computing into finance is just beginning. Collaborations between financial institutions, technology companies, and academic researchers are critical in driving the development of quantum applications in finance. Investment in quantum research. Investment in quantum computing from the public and private sectors is crucial. It will support the foundational research required to advance the technology to a level where it can be reliably used in financial applications. Preparing for a quantum future. Financial institutions need to prepare for quantum computing by investing in talent, exploring potential use cases, and staying informed about technological progress. This will ensure they are ready to harness the power of quantum computing when it becomes available. Conclusion. Quantum computing holds transformative potential for the finance sector, with the ability to process complex computations at speeds impossible for classical computers. The promise of enhanced portfolio optimization, risk management, trading strategies, and more positions quantum computing as a technology that could redefine the financial landscape. However, realizing this potential will require overcoming significant challenges, a collaborative approach to innovation, and careful consideration of the broader implications. As technology matures, the finance industry must remain at the forefront, ready to adopt and adapt to maintain a competitive edge in the quantum era. Thanks for watching.
The landscape of accounting is undergoing a seismic shift thanks to the advent and integration of artificial intelligence, AI, robotic process automation, RPA, and machine learning, ML. These technologies are not merely streamlining existing processes but are forging a new frontier in financial data management, predictive analysis, and strategic planning. This video delves into the current state and the potential future of these technological marvels in accounting. The current state of AI, RPA, and ML in accounting. Automating routine tasks. The immediate impact of RPA in accounting has been the automation of repetitive, rule-based tasks. By deploying bots to handle data entry, reconciliation, and report generation, RPA has reduced the workload of human accountants, curtailed the incidence of errors, and expedited processes that once took hours or days. Enhanced accuracy and compliance. AI and ML are proving instrumental in increasing the accuracy of financial records. These technologies enable the continuous auditing of transactions and balances by learning from historical data to identify anomalies or fraudulent activities. Additionally, AI-driven systems ensure compliance with changing tax laws and financial regulations by updating algorithms in real time, a feat that would be arduous and slow if done manually. Predictive analytics and decision-making. Machine learning algorithms are becoming adept at forecasting financial outcomes by analyzing vast datasets to recognize trends and patterns. This predictive capability is transforming how accountants approach budgeting, financial planning, and risk management, allowing businesses to make more informed decisions with a forward-looking approach. The future of AI, RPA, and ML in accounting. Cognitive automation. The future will see the emergence of cognitive automation, where AI systems will not only process transactions but also understand and make complex decisions based on unstructured data such as contracts and communications. This progression will shift the role of human accountants towards exception handling and strategic tasks as machines take over the routine and complex data processing. Real-time reporting and analysis. The evolution of these technologies will lead to the ability to produce real-time financial insights. This immediacy will transform financial reporting from a historical perspective into a dynamic tool that can help steer the organization on a day-to-day basis. Enhanced fraud detection and security. As AI and ML systems become more sophisticated, their capability to detect fraud will be significantly amplified. These systems will be able to learn from global financial transactions, spotting even the most subtle signs of fraudulent activity and enhancing the security of financial operations. Autonomous decision-making. In the distant future, we may see AI systems making certain financial decisions autonomously, such as optimizing tax strategies or allocating resources for investment. However, the complexity of ethical considerations and the need for accountability will require a careful balance between autonomy and human oversight. Challenges and considerations. Ethical and privacy concerns. The integration of these technologies into accounting raises ethical questions, especially around data privacy and the potential for bias in decision-making algorithms. Ensuring transparency in AI's decision-making processes and safeguarding sensitive financial information must be priorities for the industry. The changing role of accountants. As machines take on more of the traditional accounting tasks, the role of human professionals is evolving. Future accountants will need to become adept at managing AI systems, interpreting machine-generated insights, and providing strategic advice that goes beyond number crunching. Continuous learning and adaptation. The rapid development of these technologies requires that accounting professionals commit to lifelong learning to stay abreast of the latest tools and techniques. Moreover, organizations must foster a culture of adaptability to integrate new technologies into their financial systems seamlessly. Conclusion. AI, RPA, and ML are not just transforming accounting, they are redefining it. As we stand on the brink of what some might call a revolution in accounting, the convergence of these technologies promises greater efficiency, deeper insights, and unprecedented accuracy in the financial domain. The journey from historical record-keeping to strategic financial intelligence is well underway, and the future appears poised to offer even more profound changes, reshaping the essence of accounting as we know it. Thanks for watching.
The realms of artificial intelligence, AI, machine learning, ML, and quantum computing represent some of the most profound advancements in modern technology. Together, they have the potential to solve complex problems that are currently beyond the capabilities of classical computing. To understand the relationship between these three domains, it's essential to first delineate what each one encompasses and then explore how they can amplify each other's capabilities. Understanding AI, ML, and quantum computing. Artificial intelligence, AI, is a broad field of computer science that aims to create systems capable of performing tasks that would typically require human intelligence. These tasks include decision-making, object detection, speech recognition, and language translation. AI systems are designed to mimic human cognition and can be as simple as a set of if-then rules, or as complex as neural networks inspired by the human brain. Machine learning, ML, is a subset of AI focused on the development of algorithms that can learn from and make predictions or decisions based on data. ML systems improve their performance as they are exposed to more data over time. Deep learning, a subset of ML, utilizes artificial neural networks to engage in more abstract forms of pattern recognition, often achieving results that are comparable or even superior to human capabilities. On the other hand, quantum computing is a paradigm shift in computation. Unlike classical computers, which use bits as the smallest unit of information, each bit being a 0 or a 1, quantum computers use quantum bits, or qubits. Qubits can exist in a state of superposition, where they can be 0 and 1 simultaneously, and are interconnected through a phenomenon known as entanglement. These properties allow quantum computers to process a vast amount of possibilities simultaneously. The intersection of AI, ML, and quantum computing. The nexus of AI, ML, and quantum computing is where things get exciting. Quantum computing has the potential to accelerate the capabilities of machine learning algorithms dramatically. Quantum algorithms can process complex datasets much faster than classical algorithms, enabling ML systems to learn more quickly and effectively. One key area where quantum computing can influence AI and ML is optimization problems. Many AI and ML algorithms involve finding the best solution from many possibilities, such as routing vehicles, scheduling tasks, or simulating molecular structures for drug discovery. Quantum computers can explore many possibilities at once, which could potentially reduce the time it takes to find the optimal solution from years to seconds. Moreover, quantum computing could facilitate the development of new types of machine learning models. Quantum algorithms are inherently probabilistic, as opposed to deterministic, which means they can handle uncertainty in data in a more native fashion. This capability could be particularly useful in fields such as finance or healthcare, where outcomes are not always clear-cut and involve degrees of probability. Challenges and opportunities. The integration of AI, ML, and quantum computing does face challenges. Quantum computers are still in their infancy and are not yet widely available. Developing quantum algorithms that can run on these machines and offer a significant advantage over classical algorithms is difficult. Furthermore, quantum computers will not replace classical computers in all areas. They are expected to be used in tandem, with quantum computing handling specific tasks well suited to its strengths. In contrast, classical computing will continue to manage everyday computing tasks. Some of the endeavors that are underway. Quantum computing for AI is largely in the research and experimental stages rather than in widespread practical use. However, several projects and initiatives have shown promising applications of quantum computing in enhancing AI capabilities. Quantum machine learning algorithms. Researchers have been exploring quantum algorithms that are specifically designed for machine learning tasks. For instance, quantum support vector machines have been proposed for classification problems, a common task in AI. Companies like IBM and research institutions are working on quantum-enhanced machine learning algorithms that could potentially handle large datasets much faster than classical computers. Optimization. Quantum computing has potential applications in optimization, which is a critical aspect of AI, particularly for training neural networks. Google's AI quantum team has been working on developing quantum optimization algorithms that could eventually improve AI systems' performance by quickly finding the optimal solution among many possibilities. Quantum neural networks. Efforts are underway to develop neural network models that can run on quantum computers. The idea is that quantum properties like superposition and entanglement could give these networks the ability to process information fundamentally new ways, potentially leading to more powerful forms of AI. Quantum annealing for AI. Companies like D-Wave have progressed in quantum annealing, a quantum computing method that is particularly suited to solving optimization problems. Quantum annealing has been applied to machine learning tasks such as clustering and pattern recognition. While it's not a universal quantum computing method, it does offer a glimpse into how certain quantum technologies could enhance AI tasks. Chemical and material discovery. Quantum computers have been used to simulate chemical reactions, which could aid AI in predicting the outcomes of experiments and in designing new materials and drugs. This synergy could significantly shorten development cycles in pharmaceuticals and materials science, industries that are heavily reliant on AI for simulation and modeling. It is important to note that while quantum computers have the potential to revolutionize AI, current quantum devices are somewhat error-prone and are not yet powerful enough for many practical applications. Quantum error correction and logical qubits are areas that require further development to realize robust quantum AI applications. Conclusion. In conclusion, while AI and ML are reshaping industries by enabling machines to learn from data and make intelligent decisions, quantum computing has the potential to redefine what is computationally possible. The interplay between these technologies promises to open new frontiers in computation, allowing us to solve complex problems with unprecedented efficiency. As researchers and technologists continue to advance these fields, we can anticipate a future where AI, ML, and quantum computing converge to transform our world in ways we have yet to imagine fully. Thanks for watching.
The intersection of quantum computing and healthcare, often referred to as quantum health, signifies a transformative approach to medicine. Quantum computers, with their extraordinary computational power, are poised to solve complex biological problems, analyze vast amounts of genetic data, and create new frontiers in personalized medicine. This video delves into the prospects of quantum computing in healthcare, highlighting its potential to revolutionize diagnoses, drug discovery, and treatment protocols. Understanding quantum computing. Quantum computing is a type of computation that leverages the peculiar principles of quantum mechanics, such as superposition and entanglement. Unlike classical computers, which process information in binary bits, zeros or ones, quantum computers use quantum bits, or qubits, to simultaneously represent and process a large amount of data. The quantum leap in healthcare. The application of quantum computing in healthcare presents unparalleled opportunities. Drug discovery and design. Traditional drug development is a lengthy and costly process. Quantum computers can analyze molecular structures and reactions at quantum levels, speeding up the identification of potential drug candidates and their effects on biological pathways. This could drastically reduce the time and cost of bringing new drugs to market. Genomic analysis. Quantum computing can process and analyze genomes more efficiently than classical computers. It could enable the handling of the 3 billion base pairs in the human genome for multiple individuals at once, offering insights into genetic diseases and facilitating the development of gene therapies. Protein folding. Misfolded proteins are associated with numerous diseases, including Alzheimer's and cancer. Quantum algorithms can potentially simulate protein folding dynamics accurately, leading to a better understanding of disease mechanisms and the development of targeted treatments. Precision medicine. Quantum computers can help tailor medical treatments to individual patients by analyzing complex biological data. This could improve the effectiveness of treatments and minimize side effects by considering each patient's unique genetic makeup and lifestyle. Medical imaging. Quantum computing could enhance the capabilities of imaging technologies like MRI and CT scans. Faster and more detailed image processing can lead to earlier detection of conditions and more accurate diagnoses. Healthcare logistics. Quantum algorithms can optimize hospital operations, patient scheduling, and the supply chain of medical resources. In emergency situations, such as pandemics, quantum computing can help model scenarios and plan responses effectively. Challenges and considerations. Despite the promising advantages, several challenges remain. Technological maturity. Quantum computers are still in their infancy. The hardware is prone to errors, and maintaining the stability of qubits requires extremely low temperatures, making the technology currently impractical for widespread use. Data privacy. Quantum computing poses new risks to data security, especially sensitive health information. Robust quantum-resistant encryption methods must be developed to protect patient privacy. Ethical implications. With increased predictive power comes ethical dilemmas, such as the potential for discrimination based on genetic information. Clear guidelines and regulations are needed to address these concerns. Skill gap. There is a significant skill gap in quantum computing. Training healthcare professionals and researchers to use these advanced systems is necessary for their successful integration into the healthcare industry. Conclusion. Quantum computing holds the key to a new era in healthcare, with its promise of more effective drugs, personalized treatments, and efficient healthcare delivery. However, realizing the full potential of quantum health requires overcoming significant technological and ethical challenges. As research advances and quantum computers become more sophisticated and accessible, the dream of a quantum revolution in healthcare inches closer to reality. The integration of quantum computing into health services will not only alter medical science but has the potential to enhance the overall quality of human life. Thanks for watching.
The world is on the cusp of a quantum disruption. Quantum computing, a technology that operates on the principles of quantum mechanics, is set to redefine the landscape of cybersecurity. As we approach the advent of the quantum era, it is crucial to understand the transformative impact it will have on cybersecurity practices, threat management, and the overall integrity of digital infrastructures. The quantum threat to current cryptography. Traditional cybersecurity relies heavily on cryptographic algorithms that would not stand against the computational prowess of quantum computers. Algorithms like RSA, ECC, and Diffie-Hellman, pillars of secure communications on the Internet, are vulnerable to quantum attacks due to their reliance on the difficulty of problems like integer factorization and discrete logarithms, which quantum computers can solve with alarming efficiency. Quantum computers leverage phenomena such as superposition and entanglement to perform many calculations simultaneously, which can break these cryptographic schemes. This vulnerability has ushered in an urgent call for post-quantum cryptography, a new suite of algorithms that can resist quantum attacks. Advancing cybersecurity with quantum computing. However, it's not all a tale of doom and gloom. Quantum computing also brings with it novel methods to enhance cybersecurity. Quantum key distribution, QKD. QKD uses the principles of quantum mechanics to facilitate secure communication, enabling two parties to generate a shared random secret key, which is used to encrypt and decrypt messages. The unique aspect of QKD is that it's theoretically secure. Any attempted eavesdropping can be detected, as it inevitably alters the quantum states of the communication particles. Random number generation. Quantum computing can produce truly random numbers, which is critical in creating secure cryptographic keys. Unlike classical computers, whose random numbers are actually pseudo-random, quantum computers can harness quantum randomness that cannot be predicted or replicated, thus fortifying the foundations of cryptographic protocols. Post-quantum cryptography, preparing for tomorrow. Organizations such as NIST have initiated efforts to standardize post-quantum cryptographic algorithms to acknowledge the potential quantum threat. These algorithms are designed to be secure against both quantum and classical computers and are based on complicated mathematical problems that do not currently have efficient solutions on quantum machines. Lattice-based cryptography, hash-based signatures, and multivariate quadratic equations are some of the front-runners in this new era of cryptography. Challenges and considerations. The transition to a post-quantum world is fraught with challenges. One of the major concerns is the harvest now, decrypt later threat, where adversaries collect encrypted traffic with the intention of decrypting it once quantum computing becomes widely available. The sheer magnitude of updating the global internet infrastructure also requires international collaboration and significant investment. Moreover, post-quantum algorithms tend to require larger key sizes and more computational resources, which could impact performance and the efficiency of systems that implement them. Conclusion. The intersection of quantum computing and cybersecurity represents both a threat and an opportunity. While quantum computing presents a clear and present danger to current cryptographic standards, it also propels the development of more robust, quantum-resistant algorithms and security protocols. As we prepare for the quantum future, a balance must be struck between the urgency of transitioning to secure systems and the need for practical, implementable solutions. Businesses, governments, and individuals must stay informed and proactive as the quantum age looms. The race to retain confidentiality, integrity, and availability of data in the post-quantum world has already begun, and it's one we cannot afford to lose. So, let us all get ready for post-quantum cybersecurity management for a safer world. Thanks for watching.
Quantum computing and artificial intelligence, AI, have become pivotal in shaping the corporate governance landscape, offering unprecedented capabilities and challenges. As we delve into this intricate realm, it's crucial to understand how these technologies intertwine with corporate strategies, decision-making processes, and regulatory frameworks. The integration of quantum computing into corporate governance marks a revolutionary shift. Quantum computing, characterized by its ability to process complex calculations at speeds unattainable by traditional computers, unlocks new horizons for data analysis and decision-making. Its potential in optimizing financial models, risk assessment, and market analysis is immense. For instance, in the finance sector, quantum algorithms can evaluate market risks and investment opportunities with greater accuracy and speed, enhancing strategic financial planning. Simultaneously, AI's role in corporate governance is equally transformative. AI's ability to process and analyze large datasets enables more informed and efficient decision-making. AI systems can monitor market trends, regulatory changes, and internal performance metrics, providing real-time insights to corporate boards. This ability not only aids in strategic planning but also ensures compliance with evolving regulations and standards, a crucial aspect of governance. The synergy of quantum computing and AI presents a powerful tool for predictive analytics in corporate governance. By harnessing quantum computing's speed and AI's analytical prowess, companies can anticipate market shifts, identify emerging risks, and develop forward-looking strategies. This proactive approach is vital in an era of rapidly evolving markets and regulatory landscapes. However, the integration of these technologies also poses significant challenges. One of the primary concerns is cybersecurity. Quantum computing, for instance, could potentially break traditional encryption methods, posing risks to corporate data security. Companies must invest in quantum-resistant encryption technologies to safeguard sensitive information. AI, while beneficial in data processing, also raises concerns about data privacy and ethical use of information. Corporations must establish robust ethical guidelines and privacy policies to ensure AI is used responsibly. Another challenge lies in the accessibility and affordability of these technologies. Quantum computing, still in its nascent stages, requires substantial investment and expertise, which may be beyond the reach of smaller organizations. This creates a technological divide, potentially giving larger corporations an unfair advantage in market insights and strategic planning. Similarly, AI implementation requires significant resources, both in terms of technology and skilled personnel. Moreover, the regulatory landscape surrounding quantum computing and AI in corporate governance is still evolving. As these technologies advance, regulatory bodies struggle to keep pace, often leading to a gap between technological capabilities and legal frameworks. This gap poses risks for corporations, as they might inadvertently breach unestablished or unclear regulatory guidelines. Companies must engage proactively with regulators and policymakers to shape a regulatory framework that supports innovation while safeguarding ethical and legal standards. The impact of quantum computing and AI on corporate culture and human capital cannot be overlooked. As these technologies automate complex tasks and decision-making processes, there is a shift in the skill sets required for effective governance. This shift necessitates a focus on continuous learning and adaptation among corporate leaders and employees. Furthermore, the human element in decision-making must be preserved. While AI can provide data-driven insights, the nuances of ethical considerations, stakeholder interests, and long-term strategic vision still require human judgment. The role of quantum computing and AI in corporate governance is poised for further expansion. As these technologies become more sophisticated and accessible, their influence on strategic planning, risk management, and regulatory compliance will deepen. However, this journey is not without its hurdles. Issues of cybersecurity, regulatory compliance, and the digital divide pose real challenges that must be addressed. In conclusion, quantum computing and AI represent a paradigm shift in corporate governance, offering tools for enhanced decision-making, risk management, and strategic planning. However, their integration must be navigated carefully, considering the challenges of cybersecurity, regulatory compliance, and ethical concerns. As corporations embrace these technologies, they must also invest in human capital, ensuring that the human element remains central to governance. The future of corporate governance in the era of quantum computing and AI is undoubtedly promising, yet it requires a balanced approach that blends technological prowess with ethical and strategic acumen. Thanks for watching.
Quantum computing and artificial intelligence, AI, are two disruptive technologies that, when applied to supply chain management, can transform how businesses model, manage and execute their operations. The integration of these technologies offers immense potential for enhancing efficiency, accuracy, and speed, thereby significantly impacting various aspects of supply chain management. Quantum computing in supply chain management. Quantum computing operates on the principles of quantum mechanics, offering computational power far exceeding that of classical computers. This leap in computing ability is particularly beneficial in solving complex optimization problems common in supply chain management, such as route optimization, inventory management, and demand forecasting. 1. Route optimization. Traditional computers use classical algorithms to find the best routes for transportation, which can be time-consuming and inefficient for large-scale problems. With their ability to process vast amounts of data simultaneously, quantum computers can quickly identify the most efficient routes, reducing delivery times and costs. 2. Inventory management. Quantum algorithms can handle the complex variables involved in inventory management, such as demand prediction, lead times, and supplier reliability. By accurately predicting inventory needs, businesses can minimize stockouts and reduce excess inventory, leading to cost savings. 3. Demand forecasting. Quantum computing can analyze vast datasets, including historical sales data, market trends, and consumer behavior, to make highly accurate demand forecasts. This precision helps in better planning and reduces the risks of overproduction or underproduction. AI in supply chain management. Through machine learning and data analytics, AI brings different advantages to supply chain management. 1. Predictive analytics. AI systems can analyze past and current data to predict future trends. For example, AI can expect potential delays in the supply chain caused by external factors like weather or political instability, allowing companies to manage these issues proactively. 2. Automated decision making. AI algorithms can make autonomous decisions based on real-time data. For instance, in inventory management, AI can automatically reorder products when stocks are low, ensuring that there are no delays due to human decision-making processes. 3. Enhanced customer experience. AI can personalize customer experiences by analyzing buying patterns and preferences. This personalization can extend to supply chain management by optimizing product assortments in different regions based on local preferences. Quantum computing and AI in modeling supply chains. The combination of quantum computing and AI can improve how supply chain models are developed and analyzed. 1. Complex system modeling. Quantum computing can model complex systems beyond classical computers' capability. When combined with AI, these models can continuously learn and adapt, becoming more accurate over time. 2. Simulation and optimization. Quantum computers can simulate entire supply chains, simultaneously optimizing various components. AI can further enhance these simulations by learning from each iteration and suggesting improvements. 3. Risk management. By modeling various scenarios, quantum computing and AI can identify potential risks in the supply chain and propose mitigation strategies. This proactive approach can save companies from significant losses and disruptions. Some benefits of adopting quantum computing and AI in supply chain management. Adopting quantum computing and artificial intelligence, AI, in supply chain management offers numerous benefits that can significantly enhance efficiency, reduce costs, and improve overall performance. Here are some key advantages. 1. Enhanced computational power. Quantum computing brings unprecedented computational capabilities. It can process and analyze vast datasets much faster than traditional computing methods. This speed is crucial in handling complex supply chain problems like route optimization, inventory management, and logistics planning. 2. Improved optimization. Quantum computing excels at solving complex optimization problems common in supply chains, such as finding the most efficient routes for transportation, optimizing warehouse layouts, and managing inventory levels. These optimizations can lead to significant cost savings and efficiency improvements. 3. Accurate demand forecasting. AI algorithms can analyze large amounts of historical data to predict future demand more accurately. This capability allows businesses to anticipate market changes, adjust production schedules, manage inventory more effectively, and reduce waste. 4. Real-time decision making. AI enables real-time data analysis, allowing for quicker and more informed decision making. This immediacy is particularly valuable in dynamic environments like supply chains, where conditions can change rapidly due to weather, market demands, or supply disruptions. 5. Risk management and mitigation. Quantum computing, combined with AI, can identify potential risks in the supply chain by analyzing various factors and scenarios. This proactive approach allows businesses to devise strategies to mitigate risks before they materialize, thus avoiding potential losses. 6. Increased efficiency and productivity. AI can significantly increase efficiency and productivity by automating routine tasks and decision-making processes. This automation frees human resources to focus on more strategic aspects of supply chain management. 7. Enhanced customer experience. AI can provide insights into customer behavior and preferences, leading to better product placement, stock management, and personalized customer service. This enhanced customer experience can translate into higher customer satisfaction and loyalty. 8. Scalability and flexibility. Quantum computing and AI systems can scale according to the needs of the business, making them suitable for both small-scale operations and large, complex supply chains. This scalability ensures that businesses can adapt to changes in demand or supply efficiently. 9. Sustainability and environmental impact. By optimizing routes and inventory levels, quantum computing and AI can help reduce waste and lower carbon emissions, contributing to more sustainable supply chain practices. 10. Predictive maintenance. AI can predict when equipment or vehicles might fail, allowing for preemptive maintenance. This predictive maintenance reduces downtime and extends the life of the equipment, leading to cost savings and more reliable operations. Applications in real-world scenarios. The theoretical advantages of quantum computing and AI in supply chain management are already being tested in real-world applications. 1. Transportation and logistics. Companies like FedEx and UPS are exploring quantum computing to optimize delivery routes. AI is already being used for predictive maintenance of vehicles to reduce downtime. 2. Manufacturing. Manufacturers use AI for predictive maintenance of machinery and to optimize production schedules. By handling more complex variables and scenarios, quantum computing can further enhance these processes. 3. Retail. Retail giants are using AI to forecast demand and manage inventories. Quantum computing could further refine these forecasts, especially during peak seasons like holidays, where demand patterns are highly volatile. Conclusion. Integrating quantum computing and AI in supply chain management offers a promising future. While the full potential of quantum computing is yet to be realized, its combination with AI is already showing signs of creating more efficient, responsive, and intelligent supply chains. As these technologies evolve, they will undoubtedly become integral to supply chain modeling, management, and operations. Thanks for watching.
The integration of quantum computing and artificial intelligence, AI, is improving risk management across various sectors. This video explores the transformative impact of these technologies on risk management modeling, analytics, and applications. Quantum computing, a new frontier in risk analysis. Quantum computing represents a significant leap from traditional computing, offering unprecedented processing power. This section will delve into how quantum computing enhances risk analysis through faster data processing and complex simulations. Enhanced computational power. Quantum computers process information fundamentally differently from classical computers, allowing for quicker analysis of large data sets. Complex risk modeling. Quantum algorithms can handle more complex models, leading to more accurate risk assessments in finance, insurance, and other industries. AI and machine learning in risk analytics. AI and machine learning have transformed risk analytics by enabling predictive modeling and real-time analysis. Predictive modeling. By analyzing historical data, AI algorithms can predict future trends and potential risks, enabling proactive risk management. Real-time risk analysis. Machine learning models can monitor and analyze data in real time, identifying risks as they emerge. Integrating quantum computing and AI for enhanced risk management. The combination of quantum computing and AI is particularly potent, offering new capabilities in risk management. Advanced data analytics. Quantum computing can enhance AI's data processing capabilities, allowing for more sophisticated risk analysis. Improved accuracy. The integration leads to more accurate predictions and assessments, which are crucial in high-stakes environments like financial markets. Benefits of adopting quantum computing and artificial intelligence, AI, in risk management. Adopting quantum computing and artificial intelligence, AI, in risk management offers a range of significant benefits, reshaping how organizations assess and mitigate risks. These benefits include: 1. Enhanced computational speed and efficiency. Quantum computers can process vast amounts of data at speeds unattainable by classical computers. This speed is particularly beneficial in risk management, where analyzing large datasets for risk assessment is crucial. 2. Improved accuracy of risk models. Quantum computing, combined with AI algorithms, enables the development of more sophisticated and accurate risk models. These models can factor in a multitude of variables and complex interactions that traditional models might overlook. 3. Advanced predictive analytics. AI algorithms excel in identifying patterns and predicting future trends from historical data. In risk management, this capability allows for early identification of potential risks and proactive mitigation strategies. 4. Real-time data processing. AI and quantum computing facilitate real-time data analysis, which is vital for dynamic risk environments. This immediacy ensures that risk managers can make informed decisions swiftly in response to emerging threats. 5. Handling complex systems. Quantum computing can model complex systems that are beyond the scope of classical computing. This ability is particularly useful in scenarios like financial markets or global supply chains, where the interplay of numerous factors can be intricate. 6. Cost efficiency in the long run. While the initial investment in quantum computing and AI may be high, these technologies can lead to significant cost savings over time by reducing losses from unforeseen risks and improving the efficiency of risk management processes. 7. Scalability of risk management solutions. AI and quantum computing solutions can be scaled to meet the needs of various organizations, from small businesses to large corporations, making advanced risk management accessible to a broader range of entities. 8. Enhanced cybersecurity. Quantum computing provides advanced cryptographic techniques, improving cybersecurity measures. This is crucial for protecting sensitive data involved in risk management processes. 9. Customization and flexibility. AI algorithms can be tailored to specific risk management needs of different industries, offering customized solutions that are more effective than one-size-fits-all approaches. 10. Integration with existing systems. AI can be integrated with existing risk management systems, enhancing their capabilities without requiring complete overhauls, thereby ensuring a smoother transition to more advanced risk assessment methods. These benefits highlight the transformative potential of quantum computing and AI in improving risk management practices, offering more efficient, accurate, and responsive risk assessment and mitigation strategies. Applications in various industries. The application of quantum computing and AI in risk management extends across multiple industries. Financial services. In banking and finance, these technologies aid in credit risk assessment, market risk modeling, and fraud detection. Insurance. They help model complex scenarios like natural disasters, impacting underwriting and claims processing. Healthcare. Risk management in healthcare benefits through better prediction of patient outcomes and medical data management. Challenges and future prospects. Despite their potential, quantum computing and AI in risk management face challenges such as data privacy concerns and needing specialized talent. This section will explore these challenges and the prospects of these technologies in risk management. Ethical and privacy considerations. Balancing technological advancements with ethical considerations and data privacy is crucial. Future developments. The ongoing quantum computing and AI development promises even more sophisticated risk management tools and methodologies. Conclusion. Quantum computing and AI are at the forefront of a risk management modeling and analytics revolution. By offering enhanced computational power and advanced analytics capabilities, these technologies are set to redefine how risks are assessed and managed across various sectors. As they continue to evolve, their impact on risk management will only grow, offering exciting prospects for the future. Thanks for watching.
Preparing for the adoption of quantum computing involves a multifaceted approach for companies and organizations. While still in its nascent stages, this technology promises to transform various fields, from cryptography to materials science. Here's a comprehensive guide on how companies can gear up for this quantum leap. 1. Understanding quantum computing. Fundamental knowledge. Before diving into applications, companies need to invest in building a foundational understanding of quantum computing. This includes grasping the principles of quantum mechanics that underpin the technology. Current state of technology. Keeping abreast of the latest developments in quantum computing helps companies gauge how close the technology is to practical, scalable applications. 2. Capability building. Specialized recruitment. Hiring experts in quantum computing, such as quantum physicists and engineers, is crucial. These professionals can guide the strategic incorporation of quantum technologies into business processes. Partnerships and collaborations. Forming alliances with universities, research institutions, and leading technology firms can provide access to valuable resources and knowledge. 3. Strategic brand positioning. Quantum-ready branding. Companies should consider how to position themselves as leaders in adopting quantum technologies. This could involve marketing campaigns that highlight their commitment to cutting-edge technologies. Ethical and sustainable approach, emphasizing a responsible approach to quantum computing, focusing on privacy, security, and ethical use of technology, can enhance brand reputation. 4. Technology development and integration. Investment in research and development, R&D. Allocate resources to R&D to explore how quantum computing can solve industry-specific problems or enhance existing solutions. Infrastructure readiness. Evaluate and upgrade existing IT infrastructure to be compatible with quantum technologies. 5. Organizational design. Agile structures. Adopt organizational structures that are flexible and adaptable to rapidly evolving technologies. Cross-functional teams. Encourage collaboration between quantum experts and other departments to foster innovation and seamless integration of quantum computing into business operations. 6. Training and skill development. Customized training programs. Develop training modules to educate employees about quantum computing, tailored to various levels of expertise. Continuous learning. Encourage a culture of continuous learning and curiosity. Staying updated with quantum computing advancements should be a part of the organization's learning ethos. 7. Preparing for quantum security challenges. Quantum-safe cybersecurity. Invest in research to develop quantum-resistant algorithms and encryption methods to safeguard against potential quantum computing threats. Data privacy policies. Update data privacy policies and practices to address the unique challenges posed by quantum computing. 8. Long-term strategic planning. Vision for quantum adoption. Create a long-term strategic plan that outlines the role of quantum computing in the organization's future. Scenario planning. Engage in scenario planning to prepare for various futures where quantum computing plays a significant role in industry and society. In conclusion, the journey towards quantum computing adoption is not just about technology acquisition but also about building an ecosystem that supports continuous learning, innovation, and ethical use of this transformative technology. By focusing on these critical areas, companies and organizations can prepare for the advent of quantum computing and position themselves as pioneers in this exciting new frontier. Thanks for watching.
Quantum computing represents a transforming shift in computational technology, offering transformative capabilities for businesses and organizations. By harnessing the principles of quantum mechanics, quantum computers can process complex data at speeds unattainable by traditional computing systems. This video will explore the myriad benefits of adopting quantum computing and the risks associated with lagging behind in this technological frontier. The quantum advantage. Accelerated problem solving. Quantum computers excel at solving complex problems that are intractable for classical computers. This includes optimization issues, simulations, and data analysis. The speed at which quantum computers can process vast datasets and perform calculations enables more efficient decision-making, product development, and problem-solving. Enhanced data security. Quantum computing also offers unprecedented data security advancements. Quantum cryptography leverages quantum mechanics principles to create virtually unbreakable encryption. This is crucial in an era where data breaches and cyber threats are increasingly sophisticated and damaging. Breakthroughs in research and development. The power of quantum computing is particularly transformative in research and development. Industries like pharmaceuticals can benefit from quantum computing to model and understand complex molecular structures, leading to faster drug discovery and development processes. Similarly, in materials science, new materials can be simulated and designed with properties tailored to specific uses. Superior financial modeling. In finance, quantum computing can transform risk assessment and investment strategies. Quantum algorithms can analyze market data and economic models more comprehensively and quickly, offering insights that are beyond the reach of traditional computing. The risks of not adopting quantum computing. Falling behind in innovation. Organizations that delay or ignore the adoption of quantum computing risk falling behind competitors. As quantum computing becomes more mainstream, companies that fail to integrate it into their operations will struggle to keep up with innovation in their respective fields. Data security vulnerabilities. As quantum computing becomes more accessible, the threat to current encryption standards increases. Organizations not upgrading their security protocols to quantum-resistant encryption could become vulnerable to quantum-powered cyber attacks. Missed opportunities in efficiency and cost saving. Quantum computing offers significant efficiencies in processing speed and problem-solving capabilities. Companies not leveraging these advantages may incur higher costs and inefficiencies, impacting their profitability and competitive edge. Obsolescence in data analysis and forecasting. Quantum computing provides a significant edge in data analysis and predictive modeling. Companies relying solely on traditional computing for these tasks will find their models less accurate and slower compared to those using quantum computing, leading to less informed decision-making. In summary, adopting quantum computing is not just about keeping pace with technological advancements. It's a strategic necessity for companies and organizations aiming to remain competitive and secure in a rapidly evolving digital landscape. The benefits of quantum computing, from enhanced problem-solving and data security to groundbreaking research and development, are too substantial to ignore. Conversely, the risks of not adopting quantum computing, falling behind in innovation, data security vulnerabilities, inefficiencies, and obsolescence in data analysis, are significant and potentially detrimental to any organization's long-term success. Quantum computing is no longer a futuristic concept but a present reality that organizations must embrace to forge ahead in their respective domains. The leap into quantum computing may seem daunting, but it is a necessary stride towards future-proofing businesses and maintaining a competitive edge in an increasingly digital world. Thanks for watching.
Part 1. The Quantum Advantage and Benefits. Quantum computing represents a transforming shift in computational technology, offering transformative capabilities for businesses and organizations. By harnessing the principles of quantum mechanics, quantum computers can process complex data at speeds unattainable by traditional computing systems. This video will explore the myriad benefits of adopting quantum computing and the risks associated with lagging behind in this technological frontier. The quantum advantage. Accelerated problem solving. Quantum computers excel at solving complex problems that are intractable for classical computers. This includes optimization issues, simulations, and data analysis. The speed at which quantum computers can process vast datasets and perform calculations enables more efficient decision-making, product development, and problem-solving. Enhanced data security. Quantum computing also offers unprecedented data security advancements. Quantum cryptography leverages quantum mechanics principles to create virtually unbreakable encryption. This is crucial in an era where data breaches and cyber threats are increasingly sophisticated and damaging. Breakthroughs in research and development. The power of quantum computing is particularly transformative in research and development. Industries like pharmaceuticals can benefit from quantum computing to model and understand complex molecular structures, leading to faster drug discovery and development processes. Similarly, in materials science, new materials can be simulated and designed with properties tailored to specific uses. Superior financial modeling. In finance, quantum computing can transform risk assessment and investment strategies. Quantum algorithms can analyze market data and economic models more comprehensively and quickly, offering insights that are beyond the reach of traditional computing. The risks of not adopting quantum computing. Falling behind in innovation. Organizations that delay or ignore the adoption of quantum computing risk falling behind competitors. As quantum computing becomes more mainstream, companies that fail to integrate it into their operations will struggle to keep up with innovation in their respective fields. Data security vulnerabilities. As quantum computing becomes more accessible, the threat to current encryption standards increases. Organizations not upgrading their security protocols to quantum-resistant encryption could become vulnerable to quantum-powered cyber attacks. Missed opportunities in efficiency and cost saving. Quantum computing offers significant efficiencies in processing speed and problem-solving capabilities. Companies not leveraging these advantages may incur higher costs and inefficiencies, impacting their profitability and competitive edge. Obsolescence in data analysis and forecasting. Quantum computing provides a significant edge in data analysis and predictive modeling. Companies relying solely on traditional computing for these tasks will find their models less accurate and slower compared to those using quantum computing, leading to less informed decision-making. In summary, adopting quantum computing is not just about keeping pace with technological advancements, it's a strategic necessity for companies and organizations aiming to remain competitive and secure in a rapidly evolving digital landscape. The benefits of quantum computing, from enhanced problem-solving and data security to groundbreaking research and development, are too substantial to ignore. Conversely, the risks of not adopting quantum computing, falling behind in innovation, data security vulnerabilities, inefficiencies, and obsolescence in data analysis, are significant and potentially detrimental to any organization's long-term success. Quantum computing is no longer a futuristic concept but a present reality that organizations must embrace to forge ahead in their respective domains. The leap into quantum computing may seem daunting, but it is a necessary stride towards future-proofing businesses and maintaining a competitive edge in an increasingly digital world. Part 2. Preparing for the adoption of quantum computing. Preparing for adopting quantum computing involves a multifaceted approach for companies and organizations. While still in its nascent stages, this technology promises to transform various fields, from cryptography to materials science. Here's a comprehensive guide on how companies can gear up for this quantum leap. 1. Understanding quantum computing. Fundamental knowledge. Before diving into applications, companies need to invest in building a foundational understanding of quantum computing. This includes grasping the principles of quantum mechanics that underpin technology. Current state of technology. Keeping abreast of the latest developments in quantum computing helps companies gauge how close the technology is to practical, scalable applications. 2. Capability building. Specialized recruitment. Hiring experts in quantum computing, such as quantum physicists and engineers, is crucial. These professionals can guide the strategic incorporation of quantum technologies into business processes. Partnerships and collaborations. Forming alliances with universities, research institutions, and leading technology firms can provide access to valuable resources and knowledge. 3. Strategic brand positioning. Quantum-ready branding. Companies should consider how to position themselves as leaders in adopting quantum technologies. This could involve marketing campaigns that highlight their commitment to cutting-edge technologies. Ethical and sustainable approach. Emphasizing a responsible approach to quantum computing, focusing on privacy, security, and ethical use of technology, can enhance brand reputation. 4. Technology development and integration. Investment in research and development, R&D. Allocate resources to R&D to explore how quantum computing can solve industry-specific problems or enhance existing solutions. Infrastructure readiness. Evaluate and upgrade existing IT infrastructure to be compatible with quantum technologies. 5. Organizational design. Agile structures. Adopt organizational structures that are flexible and adaptable to rapidly evolving technologies. Cross-functional teams. Encourage collaboration between quantum experts and other departments to foster innovation and seamless integration of quantum computing into business operations. 6. Training and skill development. Customized training programs. Develop training modules tailored to various levels of expertise to educate employees about quantum computing. Continuous learning. Encourage a culture of continuous learning and curiosity. Staying updated with quantum computing advancements should be a part of the organization's learning ethos. 7. Preparing for quantum security challenges. Quantum-safe cybersecurity. Invest in research to develop quantum-resistant algorithms and encryption methods to safeguard against potential quantum computing threats. Data privacy policies. Update data privacy policies and practices to address the unique challenges posed by quantum computing. 8. Long-term strategic planning. Vision for quantum adoption. Create a long-term strategic plan that outlines the role of quantum computing in the organization's future. Scenario planning. Engage in scenario planning to prepare for various futures where quantum computing plays a significant role in industry and society. In conclusion, the journey towards quantum computing adoption is not just about technology acquisition but also about building an ecosystem that supports continuous learning, innovation, and ethical use of this transformative technology. By focusing on these critical areas, companies and organizations can prepare for the advent of quantum computing and position themselves as pioneers in this exciting new frontier. Thanks for watching.
Topic: Embracing quantum science, technologies, and computing, a guide for academics and professionals. Quantum science, technologies, and computing are transforming multiple fields, offering unparalleled opportunities for advancements and innovations. For professionals in academia, industry, and research, integrating quantum principles into their work is becoming increasingly essential. This video explores why and how academics and professionals can embrace quantum science, technologies, and computing in their current pursuits, providing practical steps, examples, and real-life illustrations. 1. The importance of quantum technologies. A transforming paradigm. Quantum technologies represent a paradigm shift with the potential to solve complex problems that are currently intractable with classical methods. Quantum computing, for instance, can perform calculations at speeds unimaginable with today's fastest supercomputers, opening new frontiers in cryptography, materials science, and drug discovery. Global recognition and investment. The global significance of quantum technologies is evident from the United Nations designating 2025 as the International Year of Quantum. This recognition is accompanied by substantial investments from governments and industries worldwide, fueling research, development, and commercialization of quantum innovations. 1. Why professionals should embrace quantum technologies. Enhancing research and innovation. Integrating quantum technologies into existing research can lead to groundbreaking discoveries. For example, quantum algorithms can optimize complex systems in logistics and supply chain management, providing more efficient solutions than classical algorithms. Career advancement and opportunities. As quantum technologies become more prevalent, professionals with quantum expertise will be in high demand. Embracing quantum science can lead to significant career advancements and open doors to new professional opportunities in academia, industry, and beyond. Staying competitive. In a rapidly evolving technological landscape, staying competitive requires continuous learning and adaptation. By embracing quantum technologies, academics and professionals can ensure they remain at the cutting edge of their fields, contributing to and benefiting from the latest advancements. Investment and initiatives. There is a substantial influx of research funds, alongside numerous research and development activities, as well as government and industry initiatives focused on advancing the quantum industry. This creates a fertile ground for breakthroughs and innovations that can transform our fields. Opportunities at universities. Universities have the chance to integrate quantum technologies into their research, teaching, and industry engagements. Many current technologies are based on quantum principles, making this transition easier. Career advancement. Embracing quantum technologies can lead to significant career and professional growth. The evolving landscape of quantum science offers profound opportunities for those willing to explore and innovate. Section C: How professionals can embrace quantum technologies. As we navigate the evolving landscape of science, technologies, and engineering, integrating quantum science, technologies, and computing into our current research, academic and professional work can open new avenues for innovation and discovery. Here are some practical steps to help you transition non-quantum areas, disciplines and practices to incorporate quantum principles. Enroll in quantum courses. Academics and professionals can begin by enrolling in courses on quantum mechanics, quantum computing, and related fields. Online platforms like Coursera, edX, and university programs offer accessible options. Participate in workshops and seminars. Engaging in workshops and seminars can provide hands-on experience and networking opportunities with experts in the field. Identify quantum-relevant aspects. Review existing research projects to identify areas where quantum principles can be applied. For example, a materials scientist might explore quantum simulations to model new materials with unique properties. Collaborate with quantum experts. Building interdisciplinary collaborations can provide new perspectives and methodologies, enhancing the integration of quantum technologies into current research. Use quantum computing platforms. Experiment with quantum computing platforms such as IBM Quantum Experience, Google Quantum AI, or Microsoft Azure Quantum. These platforms offer access to quantum computers and simulation tools, enabling professionals to explore quantum algorithms and applications. Integrate quantum algorithms. Incorporate quantum algorithms into existing computational methods. For instance, a data scientist can use quantum machine learning algorithms to analyze large datasets more efficiently. Revise project proposals. When applying for research funding or developing project proposals, highlight the integration of quantum technologies and emphasize the innovative potential of combining classical and quantum approaches. Develop interdisciplinary projects. Propose projects that bridge the gap between quantum and non-quantum disciplines, showcasing the broader impact of quantum integration. Update curriculum. Educators can incorporate quantum science and technologies into their teaching materials, preparing students for future developments in the field. Promote quantum literacy. Encourage students and colleagues to pursue certifications and courses in quantum computing and technologies, fostering a culture of continuous learning. Review your current projects. Assess your existing projects to identify areas where quantum principles can be applied. For instance, if you are working on cryptography, explore quantum cryptography methods. Understand quantum basics. Familiarize yourself with fundamental quantum concepts such as superposition, entanglement, and quantum algorithms that could be relevant to your research. Engage with quantum experts. Collaborate with colleagues who specialize in quantum technologies. This interdisciplinary approach can provide new insights and methodologies applicable to your work. Participate in quantum workshops and seminars. Attend events and seminars on quantum technologies to stay updated on the latest developments and network with experts in the field. Use quantum computing platforms. Experiment with quantum computing platforms such as IBM Quantum Experience, Google Quantum AI, or Microsoft Azure Quantum. These platforms provide access to quantum computers and simulation tools. Incorporate quantum algorithms. Integrate quantum algorithms into your existing computational methods. For example, explore how quantum optimization algorithms can enhance your data analysis processes. Revise grant applications. When applying for research funding, highlight the integration of quantum technologies and emphasize the innovative potential of combining traditional and quantum approaches. Develop interdisciplinary projects. Propose projects that bridge the gap between quantum and non-quantum disciplines, showcasing the broader impact of quantum integration. Update curriculum and courses. Incorporate quantum science and technologies into your teaching materials. This will not only enhance your research but also prepare students for future developments in the field. Promote quantum literacy. Encourage your research team and students to take courses or certifications in quantum computing and technologies. Keep up with research trends. Regularly read scientific journals, publications, and news related to quantum advancements. Staying informed will help you identify new opportunities to integrate quantum principles into your work. Be open to change. Embrace the evolving nature of scientific research and be willing to adapt your methods and approaches to incorporate quantum innovations. By taking these steps, people can enhance their research capabilities, contribute to the advancement of quantum science, and stay at the forefront of technological innovation. Let's seize this opportunity to transform our research landscape and lead the way in integrating quantum technologies. Conclusion. Embracing quantum science, technologies, and computing is not just an option but a necessity for professionals aiming to stay at the forefront of their fields. By enhancing research capabilities, opening new career opportunities, and ensuring competitiveness, quantum technologies offer a transformative path forward. Through continuous education, collaboration, and practical application, professionals can seamlessly integrate quantum principles into their current work, driving innovation and progress in academia, industry, and research. I invite all colleagues to delve into the potential of quantum technologies and consider how they can collectively contribute to and benefit from this transformative field. Thanks for watching. Don't forget to subscribe to the channel for your success. If you like this video, please give it a thumbs up.